Okay, let's look at the homework 3.2, 3.3, number 10. All right, so we have this function given, and we want to find the absolute max and absolute min over this interval from 0 to positive infinity. All right, so let's do that. All right, so let's look for a critical number. So we need to find the derivative. So f prime of x is equal to, right? So derivative of 9 is 0 since it's a constant. So you have a negative sign, so I put the negative sign here. All right, so and a 2, so 2 is just a constant. I'll put it over here. All right, then we're going to take the derivative using the quotient rule. All right, so square the bottom. So quantity x squared plus 1 squared, right? And 2 is factored out already, so derivative of x is 1 times the denominator, so quantity x squared plus 1 minus, right, x times derivative of the bottom, which is 2x. Right? So then we can simplify this. This is going to be, so you have a negative 2 here. Alright, so you have a x squared minus 2x squared, so this x and that combined together, that's going to be negative x squared. And there's 1 here, so we put 1 here, right? Then you have x squared plus 1 squared. So we can set this equal to 0, right? This is going to give you, right, 1 minus x squared, which can be factored out as 1 minus x and 1 plus x, which is equal to 0, right? And this gives you x equals plus or minus 1, right? Since we're looking at only the interval from 0 to positive infinity, we're not going to consider the negative 1, but the positive 1 is inside the interval, so we have to consider that. Right? Then I'm going to do a number line to examine the increasing, decreasing behavior of the function. Right? So starting from 0, all right, so we have a critical number at 1, right? So we can try anything between 0 and the positive 1. So I'll just try, say, 1/2 or something like that. So 1/2, right? If you put 1/2 here, so 1 minus 1/2 squared, so that's positive. This is positive with a negative sign, so that'll be negative right here, right? Then after that, x equals 2 or something like that. You see that 1 minus 2 squared, so that's negative, a negative, so that's going to be positive here, right? So you can see that the original function, so this is the derivative, derivative, right? The original function is actually decreasing here and increasing there, right? Then we'll see that the minimum happens right here at the critical number. So I'll just say f of 1 is equal to, plug in 1, so it's going to be 9 minus 2 times 1, 1 over 1 squared plus 1. Right? So it's going to be 2 minus 1, so it's going to be 8, right? So this is the lowest value. All right, the highest value is going to be this. This one is a little tricky. So it's going to be either at 0 or somewhere over here. But you can see that this function is always less than or equal to 9 because this quantity right here is always non-negative. So the largest value is going to be 9. right? But here, f of 0, right? F of 0 is 9 minus, this is going to be 0, so it's 9. You can achieve 9 at x equals 0. So this is actually the absolute max there, right? And this is absolute min. All right. All right, let's just type it in. All right, so absolute maximum occurs at 0. Then the value is 9. Absolute min occurs at 1, and occurs at 1, and the value is 8. All right, let's check that. All right, it came back, and looks like we got them correctly. All right, that's it. I hope that this was clear.